On 16 July 1994, the night sky presented an astonishing spectacle as astronomers witnessed the Shoemaker-Levy 9 comet smashing into Jupiter. This comet collision captured the world's imagination and raised a pressing question: could something like this threaten Earth? Fast forward 30 years, and the quest for answers continues. The European Space Agency's Space Safety Program is gearing up for an ambitious endeavor. They've just been cleared to prepare for their next mission, the Rapid Apophis Mission for Space Safety, or RAMSES. Join us at Youniverse Revealed as we explore the insights of the most awaited mission, the RAMSES mission. With RAMSES, the ESA aims to dive deeper into planetary defense. The mission promises to explore uncharted territories and potentially unlock the secrets to protecting our planet from similar celestial threats. But where did all this begin? For almost 20 years, scientists have known that an asteroid named Apophis will pass very close to Earth on Friday, April 13th, 2029. At first, there were concerns, but further measurements showed no immediate threat, so most space agencies stopped worrying. Now Apophis is being reconsidered, not as a danger, but as a scientific opportunity. The challenge is to design, build, and launch a spacecraft to meet Apophis within 5 years. Fortunately, there are existing spacecraft designs and some spacecraft that can be repurposed for a mission to Apophis, an asteroid roughly the size of 3 football fields. Scientists first identified Apophis in 2004. Early calculations suggested a slight chance it could hit Earth in 2029 or 2036. However, in 2021, more precise radar observations confirmed that Apophis will not pose any risk to Earth for at least the next 100 years. The 3 most important things about Apophis are: it will miss Earth, it will miss Earth, it will miss Earth, said Richard Binzel, a planetary science professor at MIT. Since 2020, Binzel has co-chaired several conferences to promote space missions for Apophis's close approach in 2029. An asteroid this large only comes this close once every 1,000 years, or even less frequently, Binzel told Ars. According to him, nature is giving us a chance to study a large asteroid up close. Earth's gravitational and tidal forces will pull and possibly shake Apophis. How the asteroid reacts can give us insight into its interior. Binzel emphasizes the importance of observing Apophis before and after its closest approach in 2029. During this pass, Apophis will come within 20,000 miles, or 32,000 kilometers of Earth's surface, closer than the orbits of geostationary satellites. He added that this natural experiment will reveal how hazardous asteroids are made, which is information we can't get without complex spacecraft missions. So this is a once-in-many-thousands-of-years experiment that nature is doing for us. We have to figure out how to watch. This week, the European Space Agency, ESA, announced preliminary approval for a mission named RAMSES. Scheduled to launch in April 2028, a year before Apophis' close approach, the mission aims to rendezvous with the asteroid in early 2029. If the ESA fully approves the mission next year, the RAMSES spacecraft will accompany Apophis during its flyby of Earth. It will gather images and data before, during, and after the closest approach. RAMSES will meet with asteroid 99942 Apophis and follow it during its safe but extremely close flyby of Earth in 2029. Researchers will study how Earth's gravity changes the asteroid's physical characteristics. Their findings will help us protect Earth from similar asteroids in the future. So, to put it straight, ESA's RAMSES spacecraft will meet up with Apophis before it flies past Earth and will stay with the asteroid during its flyby. All of this is for the spacecraft to observe how Earth's gravity affects and alters the asteroid. Patrick Michael, director of research at CNRS, says there is still so much we have to learn about asteroids, but until now, we have had to travel deep into the solar system to study them and perform experiments ourselves to interact with their surface. He further added, for the first time ever, nature is bringing one to us and conducting the experiment itself. All we need to do is watch as Apophis is stretched and squeezed by strong tidal forces that may trigger landslides and other disturbances and reveal new material from beneath the surface. The RAMSES spacecraft needs to launch in April 2028 to reach Apophis by February 2029, which is 2 months before the asteroid's close approach to Earth. To meet this tight schedule, ESA has asked for permission to start preparing the mission as soon as possible using existing resources. The Space Safety Program Board has approved this request. However, the final decision to fully commit to the mission will be made at the ESA's Ministerial Council meeting in November 2025. Once launched, RAMSES will use a range of scientific instruments to conduct a detailed survey of Apophis before and after it flies by Earth. The spacecraft will carefully measure the asteroid's shape, surface, orbit, rotation, and orientation. By studying Apophis changes during its close encounter, scientists hope to learn how asteroids respond to external forces. They will learn about the asteroid's composition and structure. They will also study its mass, density, and porosity. This information will help us understand more about asteroids and improve our ability to protect Earth from potential impacts in the future. Building and launching RAMSES in under 4 years will help prepare for a real-life situation where quick action might be needed. If astronomers discover an asteroid on a collision course with Earth, we may need to act fast. With enough time, space agencies could first send a mission to study the asteroid, and if necessary, follow up with a mission to deflect or redirect it, similar to NASA's DART mission in 2022. RAMSES will show that we can send a mission to meet an approaching asteroid in just a few years. Such a mission is key to our response to a dangerous asteroid. A reconnaissance mission would first analyze the asteroid's orbit and structure. The results would help us decide the best way to deflect the asteroid or confirm that no impact is likely before committing to a more costly deflection mission, said Richard Moisel, head of ESA's Planetary Defense Office. To make a 2028 launch possible for RAMSES, ESA plans to use the design of a similar spacecraft named Hera. Hera is set to launch in October for a mission to study the binary asteroid system that NASA's DART mission impacted in 2022. By using Hera's design, ESA can speed up the process of preparing RAMSES for launch. If RAMSES receives final approval next year, it will work alongside NASA's OSIRIS-APEX mission to explore Apophis. NASA is directing OSIRIS-APEX, which is already in space from its previous mission with OSIRIS-REx towards Apophis. However, OSIRIS-APEX won't reach Apophis until a few weeks after its close flyby of Earth, due to the complexities of orbital mechanics. OSIRIS-APEX, a larger spacecraft equipped with advanced instruments, will provide a detailed view of Apophis after its close approach to Earth, according to Binzel. He added, however, to fully understand Apophis, we need to know what it was like before the Earth encounter. Right now, we only have part of the picture. Scientists are also asking NASA to consider launching 2 science probes that were previously shelved. These probes, originally built for NASA's Janus mission, could fly by Apophis before its April 2029 encounter with Earth. But what is this mission? Janus is a mission created to launch 2 small spacecraft to study near-Earth asteroids. Now, the Janus mission was canceled last year due to delays with NASA's larger Psyche mission. The Janus probes were set to launch with Psyche. The Psyche mission aims to explore a distinctive metal-rich asteroid that orbits the Sun between Mars and Jupiter. Sadly, issues with Psyche's mission pushed the launch back over a year. Although Psyche might still reach its target in the asteroid belt, the new launch plan meant Janus could no longer visit the 2 binary asteroids it was designed to study. After spending nearly $50 million, NASA placed the Janus probes, each about the size of a suitcase, into long-term storage. At the latest workshop on Apophis missions in April, scientists reviewed over 20 different ideas for spacecraft and instruments that could study Apophis. During the workshop, participants suggested that NASA consider using the Janus probes for a mission to Apophis. Apophis is looking for a spacecraft, and Janus is looking for a mission, said Binzel. Logically and efficiently, sending Janus to Apophis should be our top priority. If launched in 2027, Janus could provide the first close-up images of Apophis before RAMSES and OSIRIS-APEX arrive. Experts believe these spacecraft are well suited to future scientific flybys of near-Earth asteroids. Each spacecraft is equipped with a high-quality visible light imager and a thermal infrared imager. These can track and capture detailed images of an asteroid system during a close, fast flyby. Binzel, a key advocate for Apophis missions, pointed out that having a spacecraft follow Apophis as it passes by Earth also holds symbolic importance. When Apophis comes closest to our planet, it will be visible in the skies over Europe and Africa. With 2 billion people watching, they will wonder, what are our space agencies doing? If the response is simply, we'll be there eventually, as with OSIRIS-APEX, it may not be very satisfying, Binzel said. As the international space community, we want to show on April 13th, 2029 that we are present and actively observing. We aim to gather as much knowledge as possible about these objects, as this information could be crucial in the future. Understanding hazardous asteroids in detail will become a vital resource for humanity.